Hi everyone, welcome to this week's KETIV's Autodesk Virtual Academy. I'm Nigel Mbayak. I'm sure that those of you who've been here do recognize me. If you haven't been here before, you're definitely in for a treat. We have been doing a couple of iLogic and design automation events here in the last couple of months, and we definitely wanted to extend that and keep that moving forward. And we found Thomas Fitzgerald, who's on this call with me as well, to help us with the presentation today. So welcome, Thomas.
All right, thank you, Nigel. So yeah, welcome everybody. Good morning for those that it's still morning. Good afternoon for those on the East Coast. Yeah, so we're going to be talking a little bit today about some design automation using iLogic, and I've witnessed a few of the videos previously, and there's been a number of design automation videos out there on YouTube and what KETIV has done, and we've shown a lot of the basic functionality of iLogic and how to work through there. But I think today what we want to do is we want to kind of look at an overview of some of the larger capability that iLogic has and what we can do that in a production environment in order to automate some of our design processes. Like Nigel said, my name is Tom Fitzgerald. I've been with Autodesk for about 6 years now. I've been a consultant working with iLogic for 10 years now, going on 10 years now. And in 2008 was my first opportunity to work with iLogic. Since then, I've almost entirely focused my time on it and how to work with customers and clients to use iLogic at a very rudimentary level, and then of course now working with Autodesk at an enterprise level and some of the things that we can do with that. So I've been teaching iLogic for about 8 years now. I had the perfect and great opportunity of working with the gentleman that initially developed iLogic prior to it being acquired by Autodesk. So a lot of exposure and a lot of time working with iLogic as it has evolved and developed into what it is today. So with that being said, today what we want to do is we want to talk about the 4 main aspects to design automation, and these aspects, these are the things that have come to me working with iLogic and with the demands and the requirements of customers that are heavily using Inventor, and they want to be able to make that process more efficient. Now, what can we do? What can Autodesk provide that will allow us to do more with less people? So these are the things that I've learned over the years, and now I apply these to any engagement that I go into. So as end users, as advanced end users that we are on this call, I mean, these are the things that we need to understand and focus on most importantly. Okay, so yes, this webcast this is just the overview. We're going to just look at a few things to get a broad stroke and understanding of design automation from an Inventor standpoint. And then, of course, we're going to be putting together some subsequent webcasts to highlight and look at each one of these aspects a little bit more closely, and maybe even some more capabilities that iLogic provides, primarily dealing with drawing automation, which to the larger picture here is something that is a little bit different from what we're going to be talking about here. So we want to keep that a focal point later on. But today, let's understand these 4 aspects, and as we go through them, talk a little bit about them, and then, of course, in later webcasts, we'll get deeper into them. So what are the 4 aspects of design automation? Well, as bulleted here, typically we need to have something where an end user can input some information. It doesn't matter. A lot of these projects that I've worked with, and even maybe some of the projects in which you're trying to put together or thinking about putting together, there's a 90% chance that not everything is going to be automated. There's going to be some information that a human being is going to have to make a decision about. And in order to do that, we have to provide either a user interface or allow the user to input some information in some fashion. So we're going to look at some of the different methodologies we can use in order to satisfy that requirement. Also, Then the next bullet point, data source. Where is the information going to be coming from? Data sources can take the shape and form of a number of different things. A lot of the things that we inherently understand when working with Inventor and iLogic is the data source typically is a model. We're going to put information into parameters or properties inside of a part file or an assembly file, and we're going to capture and use that information. So we're exchanging that data. It in itself is a data source. Some other data sources that we can use, and this is basic and default information inside of iLogic, is Excel spreadsheets. We have a means to connect to Excel spreadsheets. We can also connect to SQL databases. We can read information from XML files or text files. All of these fall into that category of a data source. Where is our information going to be coming from? Okay. The next bullet, model development. As we all know, working with Inventor, you can task a number of individuals to create a model, and there's a good probability that those models are going to be developed slightly different. They're not going to be exactly the same. So how do we accommodate that? How can we understand what a configuration might be within a particular model? How is it developed to avoid any of the complications or pitfalls we might come across in terms of inconsistencies with models? So understanding and developing a model creation plan or a standard is absolutely critical. So we're going to go over what we can and cannot, or should and should not do with models in terms of automation. And then finally, the last aspect is the logic, the rules. What are, how do models interact with one another when they're put together, or what should we do in terms of conditions? How do we express these different conditions? And then, of course, how do we plan and organize the sequence of steps that need to be accomplished in order for us to have a healthy, stable assemblies or part files, what have you, at the end of the automation process. We have to have a level of accuracy and consistency. Otherwise, what's the point of having automation anyway, right? Okay, so enough of that. These are the four main aspects. We're going to brush over these, and I'm going to kind of show a few of these off. And then any questions that may come up over this process, like Nigel said, if you have questions, please feel free to ask. If it seems like it's a little bit in-depth for the amount of time that we have, we'll save it for the end. Otherwise, we can collect them and then deal with those questions as we go. So with that said, let's kind of look at some of the things that I have in store for you guys. When working with iLogic, some of the basic things, we're going to make an assumption that everybody kind of understands some of the basic things of iLogic in terms of, how to create different parameters and the value of parameters. We can go and create all these different types of parameters and understand if they're key and add some information, and if they're going to have a drop-down list or not. So we're not going to go too deep into any of that. That should be a known. Also, some of the basic ways of understanding where the iLogic tools are up on the browser, on the iLogic forum here, or iLogic browser down here in the lower left-hand corner. Also, rules, forms, external rules. Some of these things we're not really going to touch in terms of understanding those, but this is where it's all at. So basic automation, hopefully we've all kind of understand it, where if I want to create a rule, I can go in here and create a rule, and I have my rule editor here, and these are the out-of-the-box snippets that we can utilize here in order to generate and create our rules. However, what if we want to take that a little bit further? What if we want to add more to that? Well, so one of the things that I found in terms of generating rules is to really understand and appreciate how Inventor works. One of the key aspects that I try to convey to anybody that wants to understand iLogic is iLogic can't do anything that Inventor inherently can do. It doesn't change how Inventor works, it just changes how you work Inventor, okay? So if Inventor out of the box default Inventor can't do something, iLogic is not going to solve that problem. Okay, it just is another means of working Inventor to your advantage. Okay, so understand that first and foremost. Also, you know, when it comes to basic automation, we've kind of seen some things in terms of driving parameters and connected to dimensions to change the size and shape of things, and it's a very basic way of doing it. So on a more advanced level is we want to understand how can we take information and then kind of change and automate the way we do things at a very basic level initially and then more to an advanced level. So deriving different templates that already have, you know, parameters already in them, and then allowing different customers or the clients to use some sort of UI in order to change different aspects of our templates. Like, what if I want to change the operating company within, you know, my template here? How do I go about doing it? I can have a drop-down list that basically, if it's Mississippi Power in this case, I'm going to change the template, so that way I have a single template that has enough power to it for us to be able to use across a number of different business systems or business divisions, so you don't have to recreate the wheel every single time. You incorporate information into a single template file. If I want to change the size of this template, rather, let's go to A size, you know, and it's going to change my orientation and resize it and things like that. I also have in this particular template the means to work with sketch symbols. So if I have a collection of sketch symbols within my drawing resource here, I can turn on and control different sketch symbols by using iLogic. So in this particular template, the customer that needed this, they had a lot of things going on and they need a lot of things. So there's some rules in here that I can't truly demonstrate, but further on in some of the later webcasts, we'll dive deeper into some of these rules and how I created them and what we can do in terms of drawings. Okay, so templates, that's a basic, you know, the starting point with drawing automation. You know, maybe I don't have this big project I want to put into place. I just want to allow my end users to be more consistent and efficient in terms of starting, you know, their information, their files. Drawing template, this is a good place to start. I had another company that they wanted to be able to create a file, and they wanted to incorporate all of the necessary information into that based upon user selection. So they approached me and I said, well, you know, one of the things we can do is we could create a little iLogic UI here that basically goes out and reads an Excel file and then populates information, and then we feed that information to the drawing template, and it basically synchronizes the property. So whatever property values I get from the UI get pushed to these custom properties, so that way whatever's selected in this UI, that's what shows up in the iLogic or in the iProperties on the custom tab, these different custom properties here. Okay. Another thing is a file naming wizard. You know, how do we control file naming or naming conventions? You know, that's typically a problem. You know, what do we name a file? Is it something that we manually input? Well, we always want to try to avoid manual input if at all possible. Wouldn't it be better either to have a system generate that file name for us, either by connecting to a system or by having a user input that information? You know, I can go in here and just apply some numbers. Is it a part? Is it assembly? You know, this particular customer had a lot of different locations, and now, you know, I've just gone through there and I've been able to generate this file name based upon selections, and then it's going to ask me where I want to place this file, and then I can place it and then it automatically saves it for me. Now, this isn't entirely iLogic, however, the logic behind it, the rules behind it is all iLogic. It just, in that particular situation, I was leveraging .NET Visual Studio to create the different forms, and then collect the information as it walks through the wizard. And then at the very end, what it does is it passes that information down to the file here, and then I just run this rule at the very end to do a save copy as with the derived file name and the file path that the end user selects. So the Visual Studio UI, all it does is it's a vehicle to get us to a file name and a file path. We pass that information to the template, and then it does the save copy as into that location. So, you know, it's understanding the flow of information. You know, what takes place? What do we need to do? If I was an end user and I wanted to do the same thing here in Inventor, well, I would have to do that. I would have to go and do a file save copy as, and then I have to give Inventor that information. I have to tell Inventor where is it going to be placed, what is the file name going to be doing. So the wizard that I created does the exact same thing. It's a cleaner way of deriving that file name information. Okay, so from a very basic way, from a basic level, you know, starting with the templates. That's always a great place to start with automation. Start with the templates because it creates a lot of consistency, allows for a lot of consistency. You know, beyond that, you know, once we have the templates in place, you know, either at a part file, assembly file, a drawing file, you know, what can we do in terms of creating our products? You know, iLogic Inventor inherently is a manufacturing 3D software. So a lot of things that are manufactured, welded together, bolted together, you know, things that are cut, purchased components. You know, we want to assemble, we want to put them together, and we're creating something of our own. And how do we go about doing that? Well, the biggest things to understand is what I've mentioned previously, is in terms of that flow. So let me go back here to my slideshow, and I put together this workflow for Inventor and how we use iLogic. And this is a basic workflow in terms of what we can do with Inventor and iLogic, and what we can connect to it, or what we connect from it in order to pass this information on. Okay, so some of the projects I've worked on previously in the last couple of years, most definitely, is customers coming to me and saying, you know, we have this front end, we have this sales front end that, you know, our sales individuals are out there and they're meeting with the clients, and that they have all this information and you know, these requirements, and they want to be able to generate a quote, obviously based upon, you know, the customer's needs. They want to be able to generate a quote, and then this information is stored there. It's being saved in some sort of database or some sort of system, and you know, why don't we leverage it? Why don't we reuse that information? So the flow starts, you know, when we're working with an ERP or an MRP or some other sales business system that collects information and stores it within, you know, some sort of data source, some sort of database, perhaps. Okay. Well, if it's relative information, if it's valuable information to engineering, well, we can capture that. We can peer into that database and take some of that information. Now, obviously, this is going to take a lot of research and understanding of what information does get collected and indexed into those databases, and of that information, what can we use? So there's other methodologies that we can put into place to, number one, we can directly access the database and interrogate that information, or we can create intermediate databases that peruse and parse through indexed information, and then it just takes the information that we might need for our particular project, put it into this intermediate database, and then from there we can transform that information to make it valuable to engineering. Okay, so we have some sort of data source that we can either input directly, we can populate that data source ourselves, or we can have another business system populate that data source for us. So a couple possibilities there. Once we have the data source, we need to take into consideration the logic. What are we going to do with that data? How is it relevant to what we want to do in terms of automation? If a quote number has these different parameters in it in terms of size, shape, weight, material, how is that relevant to us in engineering in terms of how we're going to put together our models, right? So the business logic and the rules of how we're going to take that information from our data source and then feed it into Inventor. Okay. Our UI, as I stated before, I would hope that we could get to the point in engineering where all the information necessary in order to create, even if we go by the 80-20 rule, if we can create and generate 80% of our products without manual interaction whatsoever, that would be fantastic. However, very rarely can we achieve that type of efficiency. So almost every single time there's going to be a requirement or a need for a UI. Some logical, aesthetically appealing, user-friendly means of inputting information to supplement the data that we're getting from our data sources in order to fully configure whatever products we're trying to create. Okay, so obviously UI is going to be critical in most projects that I work with. Feeding the information, the data, developing the logic, and then of course putting together the models consumes the vast majority of the time. UIs are fairly simple. They can be fairly simple, but I would say they represent a very small portion of the level of effort required in order to put together your configurator. Other things that we can take into consideration in terms of the UI, we can do iLogic forms as a UI. We can create Visual Studio.NET forms, Windows forms as a UI. Some things that we've seen in previous videos is perhaps using Configurator 360, and then most recently the Fusion Configure product, previously known as Configure 1 that Autodesk acquired. That has capability of being a business configurator, a sales configurator as a front end, and then passing information to Inventor and other CAD systems in order to be a configurator as well. So a lot more in terms of where information is going to be coming from a data source and a UI perspective. Okay, and then over here on the left-hand side, or the right-hand side rather, you'll see a little bit here in terms of Vault. I've had to do projects where we come in there and we put together the logic, we build the UI, we assimilate and collect all the data that is needed in order to drive the configurator. And then finally, now that we have this configuration, we want to preserve it. We want to put it in Vault. So there are methods out there that we can take information using either the Vault add-in for Inventor and then push information into Vault, or we could leverage the Vault API or the Vault data for the VDF in order to create API calls to do the same thing. So we can even extend it even further than that if we want to talk about in terms of Vault. Okay. Going back over here to Inventor, so let's apply that to one of my first models, data sets that I created. Now, 2009, I put together this this data set as an introduction of my, understanding iLogic from my perspective as a consultant working for a reseller. I wanted to be able to display what we can do with iLogic. So if anybody's never seen this this conveyor before, it's very, very simple. It utilizes out-of-the-box functionality in terms of the 4 aspects of building a configurator. We have a UI. I built this UI using Visual Studio. And one of the cool things about using Visual Studio, and this was before, mind you, 2009, this was before iLogic introduced forms and global forms. So in 2009, we only had internal and external rules. So we didn't have any other way of developing a UI other than using Visual Studio. That's one of the wizards. If you're not familiar with this tool, that we have wizards here in iLogic where we can create a rule for a dialog box. And basically, what it does here, let me go and create a new rule here. Blank rule, and then I'm just going to run this wizard, just kind of walk through it. But it allows me to browse out to a DLL. So we can create files in Visual Studio, and I'll cover this in the UI webcast later. But we can use Visual Studio, generate and create a DLL from that, and we place that somewhere, and then we can import that DLL. We can connect to that DLL for our different classes and different variables that we want to pass back and forth, or parameters we want to pass back and forth between the UI and Inventor. And essentially, when it's all said and done, it looks like this, where it's nothing more than we're adding the reference to the DLL. I'm using my iTrigger to call this DLL in order for the form to pop up. And then all I'm doing is then I'm passing information from Inventor to the dialog box. So once the dialog box opens up, I'm taking the current information from the Inventor model, pre-populating the dialog box, and then that gives an initial, a starting point for the end user to be able to see the reflection, the same values that are currently in the Inventor model as in the dialog box. So if I run that again, so if I run this again, you'll see these values are being populated from the model. If I change the model and rerun this, these values here would change. So nothing more than passing information back and forth. If I go and make a selection here, you'll see that right when I make a selection, right when I select something in the dialog box, it's going to pass that information back down to Inventor. And Inventor, iLogic is going to start running rules based upon those parameter changes. So in my rules, if I go into one of my rules here, you'll see that anytime that you see a blue syntax here for a rule, that means Inventor is monitoring that parameter. It's a recognized parameter inside my rule. So anytime overall length changes, anytime section count changes, anytime section base length 1 changes, it's going to kick off this rule and it's going to run. And anything that is associated to this rule is going to run in its particular order as well. So the order in which I place my rules can vary in terms of the outcome or the performance and behavior of our automation. Not to mention what is contained within a rule. You know, we don't want to have one rule that has all the information in it. That means that rule is going to run every single time in its entirety. Instead, we may want to break up the rules and organize the rules in a more consistent or efficient manner, so that we're focusing what tasks and what functions we want to do at particular moments in time. And we'll talk about that when we get into the rule and logic webcast later on. Okay. So creating a form, creating the logic, I'm passing the information from the form to logic. It's building my models. What about my models here? You know, let me open this guy up and we'll take a quick look at this model right here. You know, I'm using basically I'm using a base sketch here. I just have a sketch, an empty sketch that's turned off, and I'm driving the size and the shape of the individual components and the patterns here by that sketch. So from an assembly level, I'm passing that information down to the individual components, the sub-assembly components, and then it has its own rules that it's firing in order to control size and shape. okay? So passing information from an upper level down to a lower level, trickling that information down to make sure that everything is consistent. So, you know, in 2009, you know, this was what iLogic was all about. I'm going to put information into an upper level assembly, and it's going to trickle down, and it's going to change and manipulate my files. Sounds great, performs great, looks great. However, in a production environment, you know, that's not really a realistic way of doing it. That's not, most of the time, that's not how we accomplish things. You know, in a production environment, we're not always just changing the same model over and over again. You know, we have part numbers and stock numbers, and we have inventory. We have to control things in that term. So, you know, if we have a file, if we have a part that we want to use within a configuration, we want to be able to bring that part in with its metadata, its part number, its stock number, you know, all the relative business information, and then bring it into the assembly, and that way it reflects on our parts list or our BOM, and, you know, we can, you know, move that information down the pipeline. We don't just change a dynamic model. We just don't move them around. We bring them in and bring them out. So in a later data set that I put together, I kind of did that, but in more of a sense of how assemblies work. In the sense of, let's have a model that has every single variation involved. Let's bring it all into one large model, and whatever we don't want, we'll just turn that off. And whatever we do want, we'll turn that on. And that's how this next iteration, this next data set that I put together, my playset here, that's how it functions. You know, same thing, it uses a Visual Studio UI. So I have an interface rule here that does the same thing. I'm just connecting to a DLL, passing some information to it. And then I have a series of rules that fire that, based upon my UI, will change my model. And some of you may have seen this, maybe you haven't, but it's doing the same thing as the conveyor, except the fact that it's not truly changing the size of anything. All the models in here, for the most part, are static. I'm just turning on and off the different components and sub-assemblies that are required for that particular configuration. Now, in my opinion, I think that's a little bit closer to how manufacturing truly works. You know, where we're not dynamically changing files on the fly, thus changing, you know, the metadata, the parameters and the properties that are associated with it. You know, if I take a pipe and I have a threaded pipe, and maybe it has a hole in it, and I'm going to weld something to it, you know, at the end of that process, it's its own part number, it's its own item, if you will. You know, I can't just go in there and change the length of that without appropriately, you know, understanding, you know, that other information. Does that change the part number? Does it change the stock number? Is it going to change the drawing? Do I have to rev things? I mean, we have particular controls and regulations and processes in place to prevent that from happening. So what's the next thing that we need to do? Ideally, if we wanted to build a configurator, we would want to have it as closely paired or paralleled to how we truly do things in terms of design inside of a 3D application. And that leads me to my last project that I've done here. It was a simple little proof of concept. A company came to me and they said, listen, we want to be able to allow our end users to make some selections. We have captured all of our business logic in this standards. It was like a 300 and some odd page standard documentation of how everything in engineering is supposed to go. So they had cataloged or syntaxed all of their processes, all of their engineering standards in this one document. So it made things extremely easy in terms of understanding the logic and the rules. So all I had to do then was to create the models. The logic just needed to be written in a more efficient manner, and then present some sort of UI and, of course, a data source. So what I did is I created this iLogic form that does nothing more than it connects to different parameters, okay? So I have a series of user parameters here, and the reason why I did that is because through creating an iLogic form, you have the capability of connecting to these different parameters. So, you know, that seemed the easiest way of keeping everything integrated right within the Inventor environment, okay? And FYI, for those that don't know, you know, when dealing with iLogic for as long as I have, I always use user parameters. I never deal with the model parameters, okay? I never rename them, I never key them. I always intentionally, purposely create my user parameters so that way I feel like I have more control over the information. You know, what are the parameter names? What is its type? How are they organized? You know, things like that. How are they keyed? User parameters to me seem a lot more, like I said, they're much more purposeful. I think you have more control. Okay, so I always use user parameters. Just a good rule of thumb in my situation. So I have this UI. If I make different changes, say I want a ZPI type of configuration, it's a steel pole, it's 50 feet tall, and then what I'm going to do is I'm going to update my configuration, which is doing nothing more than fire in a different rule that I'm going to show you here in a moment. And then once I've updated all the relative information, then I'm going to apply the configuration. And this is what I'm talking about. Applying the information. I'm going to build this model as if I was an end user. None of these files existed in this model previously. There was no placeholders. I'm not suppressing anything. It's not in there. In effect, I'm collecting information about the configuration from an Excel spreadsheet, from a data source, and based upon that information, I'm tasking Inventor to go out, find the required files for the configuration, bring them into the assembly, create constraints on the fly to properly place and situate all the files that are necessary. Okay, so it's a fully configurable, fully editable model inside of Inventor, just as if an end user had created it from their own mind. Okay, so and at the very end of all that, once I bring all the models in, I'm also organizing them into you know, some of them into different folders. So I'm naming the components when I'm bringing them in, and then I'm placing them and organizing them into a folder so it's nice and appealing and aesthetic, extremely consistent. You know, if you look here at just how I did these bolts, I mean, none of these bolts interfere with one another. You know, this pole, as a matter of fact, is a tapered pole. So the thickness of the diameter of the pole where this bolt goes through and where this bolt goes through is entirely different. I actually had to put in logic that did a measurement based upon where these bolts are going to be at, and then peruse through the data source to find the appropriately length bolt. One of the biggest issues this particular client was complaining about was the tremendous amount of field work that they had to do, field edits. They had to modify some of this equipment on the fly in the field because they didn't know how to calculate and understand what was really required. So they would, instead of sending out, you know, 2 bolts of this length and 2 bolts of that length and then 2 bolts of the third length, they would send out, you know, a handful of bolts far too long and then put them in place and then field cut them. I mean, it was an inefficient way of doing it. So what I'm doing is I'm doing measurements to find the diameter, then based upon that diameter, look for a window or a value that fits within there, and then find the closest bolt to satisfy that length. Okay. So once again, that's nothing more than logic. If you can capture that logic in your mind, then there's means to go ahead and syntax that and put that into a rule. Okay, so with the last 5 minutes that I'm going to talk here, it's just a matter of understanding the flow of information. As I stated before, one of the first things that I'm doing here is I'm taking information and I'm going to update all my multi-value lists. So this first rule that I fire when I first open up this model asks me if I want to update the multi-value lists. And if I say yes, then it's going to read the Excel file to make sure that there hasn't been any changes. And what this allows me to do is, as opposed to hard coding all of my options here inside of the assembly file, I could have a single source. I could have a database, I could have an Excel spreadsheet, a single source of information that all of my users connect to make sure that we are all on the same sheet of music, okay? So by updating the multi-value list based upon any changes that might have happened to the data source, maybe some new vendors came online, and we have to put that information into the database for new bolts. Maybe we get it from a different vendor, or we change the cost, or their address change, or whatever that information might be. By connecting to the data source, updating the information, we're going to see that here inside of our Inventor application. Then the next thing I'm doing is, after the lists have been updated, then based upon the selections from the UI, I'm going to go out to that data source and I'm going to collect all the relative information. Okay, so I'm using the Excel data source, which is a shared variable that I do from initially. If you guys aren't familiar with shared variables, go look into those. Guys, I try to use them all the time. And we're going to go into that into the iLogic, the rule writing and the logic webcast later on about shared variables, because they're extremely valuable. So I'm collecting all the information from the Excel spreadsheet. Once I've collected it all, then I'm going to do something with it. I'm going to do something, and based upon what type of file it is, I may have to do something entirely different. So if it's a pole, I might have to do one thing. If it's a bolt, I may have to do something else. If it's an insulator, something else. So I created all these different functions to identify if it's, after it goes through this main routine, if it's an insulator, if it's a clamp, if it's a line guard, or if it's a bolt kit, it does something entirely different. It goes and it fires a different function to apply that relative information differently. It brings it into the assembly, it applies its constraints, it names it, and then it organizes it if it's a fastener in this folder. And then lastly, my last rule is a clear components. The purpose of this configurator for this particular client is they would go through the process of creating their configuration, and then if it falls into the 80-20 rule. 80% of the time it would be a standardized configuration, but 20% of the time it might be custom. Like maybe the spacing between this insulator and this insulator might be an additional inch or 2 inches because of one reason or another. So like I said, because I'm not doing anything that I wouldn't normally do as an end user, I can go in here and I can manipulate these constraints, I can manipulate these files without any concern that it would ruin anything. This is a means to get to a starting point. So they use this, they get to a starting point, and then they make any changes as necessary. Okay. And then lastly, if I want to create a configuration, I can run this rule, clear components, with nothing more that goes through the browser and just deletes everything out of there. So now I'm working with a clean slate once again. I don't have any components, I don't have any constraints, everything's cleared out. If I want to run that again, a different configuration altogether, maybe a 1/2 with a 40-foot pole, update that config, apply the configuration, and it's just going to build it for me every single time. So that, ladies and gentlemen, in a nutshell, is the overview for design automation and some of the things that we can do. Now, like I said, we're going to go far deeper into that in coming weeks. So please join us again and stay tuned, and hopefully be able to answer any questions that you guys might have.
Definitely, and thank you for that, Thomas. It's definitely we're just scratching the surface here. There's so much that can be done, and I'm sure Thomas showed definitely some of the bells and whistles here in regards to like what you can possibly get out of the end of all of this. And we will go over some of these steps specifically in future webcasts, like Thomas did mention. But it looks like we've got a couple of questions here. First one I noticed was from Baron, and can you annotate your rules? If you have a long, complicated rule, you want to add a statement to the end of it stating what that couple of lines does. If you want to show that here real quick, Thomas.
Absolutely, yeah. I try to add comments as much as I possibly can to my rules. Here's a rule that does a lot of stuff. So yeah, you can add comments and you can block your code by using the apostrophe and then to open and close different comments, and then you can use an apostrophe open bracket and an apostrophe close bracket to contain that information. So as I collapse it here, you'll see it kind of gives me an idea or a comment as to what that block of code is. So yes, very good practice. I try to use that as much as possible. As you can see here, even at the end of different lines, just adding a comment to understand what that means, and it doesn't take that into consideration at all in terms of compiling the code.
Yep, and that's all color coordinated in there. That's all everything that's showing up in gray, I guess, would be things that are commented in addition to a few other things. It looks like. Yeah. Perfect.
Absolutely. Yeah. Anything that's blocked will be, like this is blocked, so it has a comment within the bracket, so it's like a black. But anything commented out would be a gray, and it's italicized. Yes.
Perfect. So that's a way for you to figure out, or at least go through one of your rules and figure out exactly what's going on. Or you could even have somebody look at it and be like, well, that's the process it's actually doing. Let's see here. Got another question here from Sergio. Sergio noticed that a lot of this coding is similar to VBA. Is there a full VBA interpreter built into Inventor to be used for iLogic?
There isn't. However, VBA and .NET are extremely similar in terms of their architecture and structure. You can use VBA to some sense. I know individuals that use VBA in order to test out different functions and procedures. And then what they'll do is they'll take it out of the VBA editor and then paste it into a rule and then modify the code so that way it's of .NET format. So I don't particularly do that, but the thing about it is in the VBA editor you have debugging, and that becomes an extremely powerful tool in terms of writing your code. That has always been my largest struggle, is there's no inherent way of debugging information inside of iLogic, and we're hoping that that will be coming soon. So there's been talk about it, but nothing as of yet. So that is definitely the way that I would do it. If you're not comfortable with coding quite yet, that's a good place to start, because it does give you the basics of Visual Basic code writing, and it gives you that power to be able to debug to some degree.
Certainly, and looks like this has come up a couple of times here as to where can I find this recording, how soon this will be on your YouTube channel, things like that. Eric Paul is actually watching this. He's our guy who edits all of these videos, and he'll get working on this immediately after we end, and hopefully we get this uploaded this afternoon. If not, by the latest, you'll see it tomorrow morning on our YouTube channel. That link is youtube.com/KETIV Technologies. We'll probably email everyone who attended this webcast today with that email or with that video link once it does come out. And if you do have any questions, definitely reach out to us in regards to that. So that takes care of, I think, like 3 or 4 questions that came in. Killing multiple birds with one stone. So what is the advantage of using a visual editor versus iLogic generated forms?
The iLogic forms are limited in their capabilities. Depending on the complexity of your configuration project will determine if you can get away with using the limited functionality in iLogic forms, or if you should use some sort of some other IDE or like Visual Studio in order to develop your Windows forms. With Visual Studio, you have the opportunity to utilize, pick boxes and radio buttons and check boxes, and you can have different forms pop up, and you have tabs, and you can link to other files. So I mean, it's really night and day in terms of the level of functionality. And I found that if you were trying to put together a full-blown configurator where we're grabbing information from a business system and we're gonna feed it into this configurator, and then at the very end we're gonna get a fully configured model with drawings and metadata and everything else and associated documentation. Like from that we can output PDFs and DWFs and Word documents and whatever the case might be. So supplemental information, by using Visual Studio, you can make that process a lot easier. But if you're just looking as a means to input information just to update and manipulate models at the Inventor level, then by far, Windows or iLogic forms are definitely the way to go. They're a lot easier to put together.
Certainly. And hopefully that answers your question, Baron. I've got some related questions here. So one is iLogic rules, are they possible within the tube and pipe environment? That's one. And then two, can you use content center parts? Can you pull things like angles and channels for iLogic and use for assemblies and stuff? I know that second one is true. You can call for things in content center. But that first one, I'm not 100% sure if you want to answer that one for us, for Thomas, in regards to tube and pipe.
Oh yeah, I can answer it. The answer is no. No, you can't truly use iLogic with tube and pipe or routed systems very well, or frame generator for that matter. However, once you understand the power that you have with iLogic and its capabilities, you could replace tube and pipe with iLogic rules, and maybe not one single configurator, but a series of smaller configurators depending on what you're trying to accomplish. But absolutely, I've built configurators or helped companies build a configurator that worked with the oil and gas industry, where they were considering using tube and pipe, but once we got down into it and drilled down into what the requirements were, we were able to satisfy it with just regular Inventor parts, dynamic parts, and an iLogic.
Certainly, and hopefully that answers your question. We'll move on to the next one. We have a lot of questions. I'll make sure to answer them all at some point. I don't know if we'll be able to do them all live, but if I don't get to your question, I'm not ignoring you. It's just something that we'll cover after the fact via email or something. So this one comes from Reed. There seems to be a whole lot to know before one can even get started with using iLogic in regards to the syntax and things like that. What's the best place to be able to start understanding that? If you want to chime in here, Thomas, I think there's definitely a lot of resources in regards to online. You can certainly reach out to us here at KETIV, and we do have some of our some of our iLogic implementers, some of our application engineers can definitely help you out in regards to finding out more about things like this. Thomas, do you know of any really good learning resources as well?
Absolutely. I couldn't have said that better. I think first and foremost, as we know in this day and age, YouTube, just do Google searches in terms of trying to gather more information about iLogic best practices and some of the things. But most critically, I think your best place to start is if you don't understand Inventor, if you're not an Inventor expert, you're going to struggle. Like I said in the beginning of the webcast, iLogic doesn't do anything that Inventor can't do. So without understanding how Inventor works, you're going to have a challenge. Secondly, I'm not a code writer. I've never taken any code writing classes before in my entire life. I've referenced a couple of Visual Basic books that I've gotten at Barnes and Nobles and things that I've written online, and that really helped out a lot in terms of some of structure for doing loops, procedures, functions, how to pass information back and forth within rules. And then lastly, just like Nigel said, lean on your resellers, guys. These people work most closely with us. We as consultants have the type of exposure that manufacturing companies working in an engineering company or engineering firms, you guys don't have. And we are the source of knowledge. We're out there. We're constantly being affected and influenced by a lot of different projects and a lot of different customers with a lot of different needs. So we've seen a lot. Please, lean on your resellers, and then they'll lean on us at Autodesk, and we can provide as much information as we can.
Certainly, and yeah, like you mentioned, and if you're more into the personal, or not personal training per se, but if you're more into like that one-on-one training or group training, things like that, we do have resources for that as well. So if that's something you want to do, a traditional learning course, perhaps in iLogic, we can definitely set something up for that, kind of get you started. It's definitely not something you can learn in 30 minutes, which is why we didn't fit it in one webcast, obviously. But once you get the ball rolling, it becomes a little bit easier as you move forward. So I'll go ahead and cover one more question here. Let's see, in regards to the future sessions. So what are they gonna? This question comes from Naveed. Will they include further sessions? Include a breakdown of how to create, some of these assemblies from start to finish? Are there videos available? Things like that. I don't think we have enough time to cover the start to finish, blank to full slate for a lot of these rules and configurators. Thomas, do you want to kind of go over a couple of the things that you're looking into doing for the next few webcasts?
Yeah. Well, if we did a video that covered the front to, or from beginning to end process, we would have by far the longest video on YouTube for sure. So that's not going to happen. But the subsequent webcasts will go into the best practices of each one of those aspects. One of them, of course, being model creation. What are we going to take? What do we need to take into consideration in terms of single part models, assemblies, and then sub-assemblies as well? So we have to treat each tier, each level individually, because as we break down into, as we go into these next webcasts and to start talking about the Inventor API, you're gonna understand that those are very critical. Where do my models reside within the hierarchy? So yes, we're going to be going into some of that stuff for sure.
Certainly. So yeah, like Thomas mentioned, if I want to reiterate that, creating a configuration like this or creating these rules, it's not like a 1-hour process. It's not a short, I can get this done in a week kind of deal. It's a little bit more than that. So definitely, if you want to know the scope about some of this, definitely reach out to us. We can help you guys reach out to Thomas as well if you have any questions for him. And then the last question that came up a couple times is in regards to these data sets, are they available, Thomas?
Yes, absolutely. Like I said, the conveyor and the playset are readily available. And if you can't find them online, I can provide them. They've been around for, like I said, many years now, so there's nothing proprietary in there at all.
Certainly. Yeah, so if that's something we can add to the follow-up email, we'll definitely go ahead and do that, see if we can get maybe a Dropbox link going and stuff like that. So again, I'd just like to thank you, Thomas, for being here today. We'll have one of these sessions probably in the next couple of weeks. No set date yet, but expect it probably end of March, probably. We'll take a look at our schedules and see when is best to do something like this. And just like to reiterate, if iLogic is something that you and your team want to leverage, us here at KETIV, we can definitely help you get started. Whether it's you need to talk to one of our application engineers and figure out if iLogic is the solution for your problem, we're more than welcome to have a conversation with you about that. If you need to forward a question to Thomas or anyone on the Inventor iLogic team, we can send that out too for suggestions. I know they're looking for suggestions in regards to improving the product moving forward. And if you have any of those suggestions, definitely let us know. We can pass those on to Chris Mitchell and his team. So again, thanks for being here today. And if you have any questions, reach out to lifeline@KETIV.com. They're on your screen. Call that phone number, or even email us at questions@KETIV.com if you've got just a general question. So again, Thomas, I'd like to thank you for being here today.
You are very welcome, guys.
Certainly. So thank you all for being here, and we hope to see you for the next session. So have a great day and enjoy the weekend.